Hey YouTube, yeah, it's been almost 2 whole months since Christmas, but it's taken that long for the shop to warm up here in Western Pennsylvania. So we're just now getting around to unboxing the new Christmas toys. Got a big project coming up here, and I got 2 new toys, both of which are gonna be helpful. Today, we're gonna talk about this Kreg Precision Miter Gauge and how it's gonna complement the sled that I have on my table saw. Alrighty, in the box, we've got the obligatory instruction manual, the actual aluminum extrusion that will be the fence of the miter gauge, the 2 big pieces that form the stop block that slides along here, the handle that tightens down the angle, the actual miter bar and gauge, measuring tape for the top of this, and the obligatory bags of hardware. This is the brass stop pin for the preset angles on here. This was just in the box loose, so make sure you don't lose it. First bag of hardware you need is this little one that has the 2 handles in it and this funny stepped nut. That thing goes down here at the base of the miter gauge with the step so that you can slide it into the T-slot on the table saw. Throw the centering pin in the hole for 0 degrees and then using the nylon washer with the handle on. Bag of hardware number 2 has these goofy little nylon threaded inserts. These are what adjust the width of the bar. So pick your favorite side, doesn't really matter which one, and thread these things in until they go all the way through and just start to poke out the other side. Be careful doing this. These nylon things are ridiculously easy to cross thread in here. They do give you a couple of extras, but you still don't want to waste them. So the directions at this point say that you're supposed to take this thing over to the table saw and adjust these nylon screws until you get, quote, the correct fit in your T-slot. But they're not real specific about what the correct fit is or how exactly you're supposed to get all 5 of these screws set correctly. So I don't know if this is right or not, but here's what I did. You're looking for a friction fit where this thing is nice and tight in the slot, doesn't move left and right at all, but you also don't want it to bind. You shouldn't feel resistance when you push it. So start with the first screw, advance it until it binds, back it off just a little bit, and then work your way down the gauge. And let me tell you, adjusting these screws, I mean, we're talking 1/12 of a turn here. It's itty bitty little motions. I kind of wish they had a finer thread on them, but maybe in the nylon you can't do that. Now on my low rent $60 Craigslist table saw, it turns out that the T-slots are not precisely the same. If I adjust the Kreg jig for this slot, it's too tight for that one. If I adjust it for that one, it's too loose in this one. I'm right-handed, and I'm more likely to notice too tight than I am to notice just a little bit of slop. So I'm going to leave it adjusted for this slot. There are 6 little high molecular weight plastic glides that snap into the bottom of the main fence of the guide. They are bugger all hard to push in with your fingers. So get them started in there and then persuade them into place. There are 2 hex head bolts with knobs for nuts that hold the fence onto the main part of the guide. The instructions show you sliding these bolts into the fence and then putting the whole thing on here, but I actually think it's easier to start them like this and then just feed the fence on. Okay, one more piece we can assemble while we're here on the bench is the stop block that attaches to that thing. The diagram shows you exactly the order that these parts go in. It's 6 1/2 dozen the other, whether you want to push these bearings in here ahead of time or you want to let the bolt do it. There's also a small and a large hole on this part of the guide. The bushings go into the large one, whereas this piece they call the support button goes into the small one. There's a T-head bolt that goes up from the bottom of this and connects to the last of your handled nuts. This is how the whole thing is going to attach to the top of the fence. You want this thing drawn together, but you also want it to be able to move freely. So go easy with the wrenches. This little gizmo is the sight glass that's going to give us the line on the measuring tape that we have yet to install on the top of our fence. We still have to calibrate this, so just tight enough not to lose it for now. Okay, small change of plans here, YouTube. I'm on the left side of the blade getting set up, and that is because the self-adhesive measuring tape that attaches to the top of the fence reads left to right for increasing numbers. That's going to be kind of a pain. If I put it on the right, I'm going to end up reading this thing upside down all the time. Although, as it is, I'll probably end up on the right anyway and reading it backwards, but so be it. You're supposed to cut this thing at the 1 inch mark, and then again at 25 inches. I don't know what you do with the other half of this. Start it at the floor and convince your kid they're getting tall. I'm going to line up the 1 inch here and stick it down. I'm just going to work my way back, trying to keep this thing as centered in the groove as I can. Well, either the tape is off or the fence is not precisely 24 inches long because it's dead nuts on this end, the line with the 1, and it's about a 1/64 of an inch longer on the tape to get to the 25 than it is the aluminum. But no matter, that is well within the range of the adjustability of the pointer on the stop. So even if I end up moving this thing over to this side and having to work backwards off the tape, it's not going to matter. All right, slide the stop on here in the T-track. Okay, time for our first little bit of calibrating. I've got this steel ruler here right up against the blade, which is exactly 1 inch wide. I'm going to loosen up the fence and I'm going to slide it over to, I don't know, plus or minus a 1/4 inch away from the blade. I want the workpiece supported close to the blade when I make the miter cuts, but you know, I clearly don't want to cut the fence. I'll tighten that back down, and I'm going to slide this foot over here until it just pushes up against the blade. So now I know the foot is exactly 1 inch from the blade. I can loosen the screw on top of the foot, put on my glasses so I can see something, and line up the line in the sight glass exactly with the 1 inch mark on the tape. Okay, with that all set up, I can put the last of the parts in there. It's a hex head bolt with this aluminum sleeve and a nut to hold it in place. It slides into the same T-track on the back that holds the fence to the miter plate. This serves as a stop for the fence so that you can slide it forwards when you make miter cuts and then get it back without having to go through this whole alignment process again. Time for a test cut. I'm setting the guide to 4 inches. I'll flip the foot up out of the way, make a squaring cut to make sure my stock is exactly flat on that end, then put the foot down and make my next cut, which should be precisely 4 inches. All right, let's see how we did here. It's 0.02 over. I think I can live with that. Okay, this thing supposedly comes factory calibrated. What does that mean? It means that with it set on 0 degrees right here, this fence and this T-slot track really are as close to 90 degrees as you're likely to get it in a home shop. Which means if I make a cut and I don't get a 90-degree cut on the end of the board, it's actually the table saw that needs to be adjusted. In my case, there's some screws in the back that I can tweak the whole motor assembly left and right. I'm hoping I don't have to do that, but I won't know until I run this freshly jointed edge and face through here and see what I get. Moment of truth time, folks. Well, I know these squares are not the most accurate things in the world, but it's the most accurate one I have for checking a large thing like this. And you can't see this because it's not backlit for you, but I do have a little bit of a gap on this end of the thing. So the blade is not, as it turns out, exactly parallel to the T-slots. Gonna have to fix that next. Folks, when you go buy yourself a table saw, do yourself a favor and get one where you adjust the tabletop instead of the motor. This is a giant pain. Well, the saw calibration was clearly long overdue because now this thing is perfect. Well, 90s are fun, but 45s are really what a precision miter gauge is for. So I've swung this thing around to 45 degrees. I haven't checked it with any kind of a protractor or stop or anything. I'm just going to trust the guide pin that they have set up there. And I'm going to loosen up this fence and I'm going to slide it towards the blade, clearly not all the way. Now, My fence here, the tape on it is not accurate. I could take the time to set it up to be accurate. For this case, I'm just testing the angle, so I don't care. I'm just gonna set this thing someplace and cut. But if you need to set that up, clearly you could. For my test process, I cut 4 sticks of scrap plywood, and I'm cutting the 45-degree angle on both ends of the same piece using the Kreg jig. I don't want to use the offcut because if my angle isn't quite 45 degrees, I'll get complementary angles that'll still miter up well when I put them in the clamp. This way, if there's any inaccuracies, it'll be multiplied by 4 rather than offset by using the other half. Okay, I'm going to bring these 4 pieces over here to the workbench and just clamp them up in a band clamp real quick. See what these 45s look like. Okay, well, if you'll forgive the shaky camera work, there's 1, 2, 3, 4. Number 3 is not perfect, but if you look real close, you can see that it's tight at the outside and it's tight at the inside. It is in fact a perfect 45, but somebody needs a new blade. I chipped out the plywood here a little bit, so I can't blame that on the Kreg jig. Well, there you have it, YouTube. Unboxing, assembly, and first impressions of the Kreg Precision Miter Gauge. I'm not going to go so far as to recommend this thing because I've only had it out of the box for 2 hours. Time will tell whether it's really worth what it costs or not. But it's by no means the most expensive miter gauge you can buy. It is all aluminum construction. The only plastic piece on here is the phenolic handle, which is fine. If you don't like it, make a wooden one. It is a wood shop after all. I get my blade problems sorted out, and I'm pretty confident this is going to handle everything I need to throw at it for the next project or 2 anyway. Questions or comments, leave them down below. While you're there, think about that subscribe button. And as always, especially if you're going to play with a table saw, stay safe, YouTube.